everyone, welcome to the first video of Process Engineering Simplified series. So in the first video of this series, we will be discussing our unit related confusions that process engineer normally face during their work at industry. So let's begin. So before going further, first of all, let me introduce myself. I'm Lakan Singh Meena. I'm BTech in Chemical Engineering from IIT Bombay. I have 8.5 years of experience in process engineering. Then I'm B certified energy manager and currently working as a lecturer in a private university. So let's begin. So let's discuss about the unit of pressure. So we all know that SI unit of pressure is Pascal and other units are bar, ATM, PSI, other uh, and pressure is basically force per unit area. So its unit actually comes out like Newton per meter square. This 1 Pascal equal to 1 Newton per meter square. However, you must have seen a unit kg per centimeter square used widely used in industry. So people normally can get confused that how this kg per centimeter square could be a unit of pressure. So the actual thing is that it is a kilogram force per centimeter square. So, but in short, it is written and even spoken as kg per centimeter square, and 1 kg per centimeter square is equivalent to 0.98 bar, so roughly equivalent to 1 bar. So this is the actual unit. This is similar to the PSI. PSI is also spoken as pound square inch, but it is pound force per square inch, and which is equivalent to 1 bar is equivalent to 14.5 psi. So this is about this unit. Now let's discuss about let's clear the confusion of absolute and gauge pressure. So basically, see this. Suppose this is the vacuum and this is atmospheric pressure, uh, and this is the pressure that we are intended to measure. Then this uh, gauge pressure scale actually start above this atmospheric pressure scale. So, so the gauge pressure shows this much pressure. However, the absolute pressure scale actually start from vacuum. So this is the absolute pressure is actually gauge pressure plus atmospheric pressure. So hope this confusion is clear. Let's confusion of energy and power. So in schools and colleges, we normally study that the unit of energy is joule. So, however, in industry, you will see that calorie is basically used mostly, and the conversion is quite straightforward. It is 4.18 joule equivalent to 1 calorie. So, if it is 1 kilocalorie, then it is 4.18 kilojoule. And the unit of power is basically energy per unit time. So, it is unit of power is watt, and 1 watt is equal to 1 joule per second. So I hope the confusion between energy and power is almost clear. And you must have seen a unit kilowatt hour. This 1 kilowatt hour is equal to 1 unit, and it is basically means it is the unit a billing unit basically. Normally everywhere in the world, based on this unit, this electricity is billed. So basically, this kilowatt hour is basically unit of power, energy, not power. And 1 kilowatt hour, if we actually simplify, so it becomes 3.6 into 10^6 joules. So since this is a unit of joules, so from there we can clearly see that it is unit of energy. And so 1 unit is equal to 3.6 into 10^6 joules. Okay. So hope this confusion is very much clear. Let's understand some prefix, although I believe everyone knows about this. So like deca stand for 10, hecta stand for 100, kilo stand for 1000, mega stand for 10^6, and giga tera. Similarly, deci, centi, milli, micro, nano, pico. These are some of the things, some of the basically prefix that are basically used. So from this video, and if you want to learn more, you can download this chemical engineering helpers app, which is absolutely free and available on Play Store, from where you can actually get lots of study material also. And these slides will also be uploaded there, so you can download it from there absolutely free. Thank you.